Hello everyone, today we will derive the formula to find the distance between any two coordinates. So let us begin. So usually this formula we will derive it using Pythagoras theorem. And you may already know Pythagoras theorem, which is applicable for right angle triangle where the hypotenuse square is equal to the square of base and height. So first of all, in the screen you can see a graph in which we have located two coordinates A and B. There are 2 points, point A and point B, and the coordinates of point A are x1, y1, and the coordinates of point B are x2, y2. So these are both points lie in the first quadrant. So the both are positive. That is, the x coordinate is positive as well as the y coordinate is positive. So now let us begin. So first of all, you need to do some constructions in order to prove the formula or to derive the formula. So for that, you need to draw the perpendiculars from point A and the point B to the x-axis. So here you can see I have dropped the perpendicular from point A as well as from the point B and named the point on x-axis as M and N. So here you can see these points are labeled as M and N. So as this AM and BN are perpendicular, it will make the 90 degree with this axis. So the coordinates of the point A are x1, y1 and the coordinates of point B are x2, y2. So now first you should find the distance of this AM, BN from the coordinates. So here it is same distance. So OM, the point OM is x1. See, here you can see we are asked to find OM and here the coordinate is x1. So the distance of OM is x1. And same after that ON. So in the figure you may refer ON. Here the coordinate is x2. So the distance between O and N is x2. So now the next MN. So if you carefully observe MN, directly we don't have any point to locate the distance between these two. But if you observe carefully, Mn is equal to On minus Om. Here also you can see the same. Mn is equal to On minus Om. And already we have found the distance of On as well as Om. See up here you can see, and only we need to substitute the values On which is equal to x2 and Om which is equal to x1. So the value of Mn is x2 minus x1. So now let us move towards the y coordinates. Now NB. In the figure you may see N and B. So here they meet at y2. So the distance is y2 and NC. If you move towards NC, N and C, you can see here there is no specific point labeled, but from here you may refer that this point will be y1 as this point is x1. So the point C will be y1. So the distance NC is y1 and BC. If you see in the figure BC, we need this measurement BC. So if you carefully observe, BC is a part of this big line BN. So BC is equal to BN minus CN. Here you can see BC is equal to BN or NB minus CN or NC. So already we have the distance of NB and NC. Just we need to substitute and we get BC is equal to Y2 minus Y1. So now we have found all the distances and just now we need to substitute. And before that we need to draw one more perpendicular from point A on this BN. So now I have drawn one perpendicular from point A on the line BN. So the angle BCA is 90 degree. As perpendicular means we are dropping a right angle. So the angle C, that is angle BCA, is 90 degree. Now if you only consider this right angle triangle, that is triangle BCA. Now I have zoomed this figure. See, you can see triangle BCA. Now consider right angle triangle BCA, which is right angled at angle C. Here you can see it is right angled at angle C. Now you may already know Pythagoras theorem, in which hypotenuse square is equal to the sum of squares of base and height. So now hypotenuse, in this particular triangle, the hypotenuse is AB. So you will write AB square is equal to base, that is AC square, plus height, that is BC square. So AB square is equal to, now the AC value. We have the value of AC, which is equal to, if you refer to the figure, we will definitely get the value. So actually we have not wrote the value of AC, but if you carefully observe, AC is equal to Mn, as these both lines are same and this is a square. So AC is equal to Mn, and already we have wrote the value of Mn, which is equal to x2 minus x1. So same value we will consider here. That is, AC is equal to x2 minus x1, and this whole square will come as it is. Now plus BC value. Now if you see here, the value of BC is y2 minus y1. So let me show you it more clearly. The value of BC is y2 minus y1. So here also we will consider the same value, that is BC square, which is equal to y2 minus y1 whole square. So now we will simplify this equation. And here we have square. If we send the square to the right hand side, it will become square root. So just that only we have did here. So AB is equal to under root of x2 minus x1 whole square plus y2 minus y1 whole square. Or we can also write this formula as under root of x1 minus x2 whole square plus y1 minus y2 whole square. We can interchange x2 here or x1 here. That is on your choice. So now we have successfully derived the formula. As you can see, this formula we meant to derive. And in this step only we have derived the formula. It is a very easy process. Hope you understood. Thank you for hearing. Thank you.